Hi, this is Julie Harland, and I'm your Math Gal. Please visit my website at yourmathgal.com, where you could search for any of my videos organized by topic. This is part one of absolute value inequalities. We have an introduction to the meaning of the absolute value inequalities, and we just go over the problems that have less than or equal. So we do these 4 problems on this video. Below are some examples of absolute value inequalities. So notice there's some absolute value signs with something inside of it. And the reason it's an inequality is we have some less than or greater than symbols, or might have less than or equal, etc. Now keep in mind, the absolute value, we're always referring to something's distance from 0. So what would this mean? The absolute value of x is less than 3. This would mean we're trying to find the numbers x whose distance from 0 is less than or equal to 3 spaces. Okay, so let's just look at a number line. So the question is, where can x lie? Its distance from 0 is less than or equal to 3 spaces. So there's a lot of places x could be, right? So where's some places that x could be? X could be at 0, right? That's less than 3 spaces away from 0. It's only 0 spaces. It could be here at 1/2. It could be here at 2. It could be over here at -1.5. And in fact, it could be exactly 3 spaces away. It could be over here at -3. So basically, x could be anywhere in between 3 and -3. Think about that. X could be anywhere in this range. So the solution here is that x can be any of these numbers, right? Any number between -3 and 3. Because wherever you place it, the distance from x to 0 will be less than or equal to 3 spaces. So the solution to this problem, actually, if I were to write it in interval notation, is that it's in between -3 and 3, just sort of reasoning that out. Now, what's another way of thinking about this? Don't even think about the graph for a minute. What could x be? What number could you put in for x, so when you take the absolute value, you'll get a number less than 3? Well, you could put 2 in, that'll work, right? You could put in -2, that'll work. You could put in 2.5, that'll work. You could put in -2.5. You could put any number from 0 all the way up to 3, right? And you could also put in some negative numbers, but you can't go below -3. For instance, if you put in -3.5 for x, once you take the absolute value, you'd have 3.5, which is not less than 3. So you get exactly the same solution, reasoning through it. SOLN is my little substitute of writing out the whole word solution. So it's also going to be the exact same solution. So you could think of it in terms of a number line and distance, but you could also think, well, what numbers could you put in for x in between -3 and 3? So it's not so difficult when you just have an x inside the absolute value, but let me give you one to try. And by the way, if there was no equal sign here, it couldn't be at -3 or at 3. It'd have to be between. So I'm going to give you one like that to try. All right, so here's a problem for you to try. Absolute value of x is less than 2. So I want you to solve it and then graph the solution on the number line. Okay, well, it's almost like that previous problem, except the numbers have to fall between between -2 and +2. But it can't touch, so if we were going to graph it, we would use the open parentheses here. And in interval notation, we'll use parentheses in between -2 and 2. Now, keep in mind, this is not an ordered pair. That wouldn't even make sense to put in an ordered pair for x. So in the context of the problem, this is our solution using interval notation. How about if I had this problem? Absolute value of x plus 1 is less than or equal to 8. The key is to first isolate the absolute value. So this just says solve. We're not going to also graph it. So before trying to figure out the solution, you want to subtract 1 from both sides. All right, so what does that give you if you subtract 1 from both sides? We have absolute value of x is less than or equal to 7. So our solution will be in between what numbers? It'll be in between -7 and +7, which written in interval notation is -7 to 7. Now you could always check one of the answers and see if it's true. It's impossible to check every solution, but you could just do a little check. Pick a number between -7 and 7. How about checking what happens when you try -5? Does it make this original inequality true? So if you put in -5 for x into the original problem here, the question is that a true statement? Okay, that's all you're asking. You certainly can't check every number. So if you do that, the absolute value of 5 is what? The absolute value of -5 is 5. And is 5 plus 1 less than or equal to 8? Remember what this means. It could either be less than 8 or the answer could be actually equal to 8. And in this case, it will be less than, right? Because 6 is less than 8. So yeah, it checks. All that makes sense. All right, moving on. What if we have something like x plus 3 in an absolute value sign? So we can't just subtract 3 from both sides because the 3 is inside the absolute value sign. So now what's inside the absolute value is not just an x, it's an x plus 3. We could still think about the number line to reason this out. So what it's saying is whatever's in the absolute value can be up to 4 spaces away from 0. Right? So if here's 0, and that's -4, x plus 3 could be anywhere up to 4 spaces. So it could be here, right? X plus 3 could be anywhere between 0 and 4, right? Or x plus 3 could also be anywhere between -4 and 0. So whatever's inside that absolute value, it's not an x this time, it's an x plus 3. Whatever's in there, in this case it's an x plus 3, has to be between -4 and 4. Just like when it was x, we put that x would be between -4 and 4. So now we have this compound inequality to solve. So let's subtract 3 from all 3 parts here. And we get -7 is less than x is less than 1. Remember, the goal is to solve for x, not to solve for x plus 3. And I forgot to put the less than or equal. There we go. So notice in my picture here, I'm just showing where x plus 3 could be. X plus 3 could be anywhere here, right? That's not where x could be, that's where x plus 3 could be. X has to be in between -1 and 7. I'm sorry, I said that backwards. -7 and 1. So let's see where 0 is. Let's see, -7, 5, 3, 1. There's 0. Okay, so it would be any number in between -7 and 1. Now, let's see if that makes sense. What if it was exactly -7? Go back to the original. Put in -7 for x. So I'm going to get on another sheet of paper so you can see that. So here was our original problem. Absolute value of x plus 3 is less than or equal to 4. And we got the solution, that it was between -7 and 1. So does that make sense? When we plug in negative 7, we're just going to check some things. What if it's negative 7? Because that's one of the solutions. Well, if you put in negative 7 for x in the original, this becomes the absolute value of negative 4. And is this true? What's the absolute value of negative 4? It's 4. And is 4 less than or equal to 0? Remember, your question is 4 less than 4 or is 4 equal to 4? And the part 4 equals to 4 makes it true. So that works. So negative 7 was the solution. Let's pick some other number in there. How about 0? What if you checked 0? So this is just sort of convincing yourself that some of those numbers in there work. So if you put in 0 for the x, absolute value of 3 is less than or equal to 4. Now, is that true? Well, what's the absolute value of 3? Oh, it's 3. So yes, 3 is less than 4 in this case. So our answer here is correct. Not because I just tried those two things, but because of all the reasoning. Now here's the other way to reason it. What could be inside of this? Absolute value. X plus 3 is inside. What number could you put inside here? Whatever's inside of here could be any number between 0 and 4. Think about it. So if the number inside of here was a 1, it would make it true, right? After you simplified it, or after you simplified if it was a 3, or what about if it was negative 2? That would work, because when you took the absolute value of negative 2, it would end up being less than 4. Or you could try whatever simplified to be negative 3. So what's inside of there, your x plus 3, does it seem reasonable to you that whatever's inside of there, if you simplified it and you got anywhere between negative 4 and 4, when you took the absolute value of it, you would still get a true statement, right? So if x plus 3 was equal to 5, it would not have worked, right? That's a number bigger than 4, because that wouldn't work. Or if x plus 3 was negative 5, it wouldn't work. So you have to take what's inside the absolute value, and it has to go in between the negative 4 and the positive 4. There is a lot more to solving absolute value inequalities than I've covered so far on this video, so I hope you'll watch the rest of my videos on this topic. So far we've only covered problems that have the less than or equal, such as absolute value of 2x minus 5, for instance, is less than or equal to 9. And here's how we would do problems in that form in general. So if you have the absolute value of something, all right, I'm going to just call it stuff. It might be x, it might be 2x minus 5, in the absolute value sign, less than or equal to k. K is just a positive number. K is greater than 0. This is how we solve that inequality. We write this equation, this inequality that does not have an absolute value sign. You take the stuff in the absolute value and you put it in between negative k and k. So we write negative k. So if k was 5, we'd write negative 5 is less than or equal to whatever stuff that is less than or equal to 5. In the next few videos, we'll be doing some problems of this form where we have less than or equal. And then after that, we'll move on to how to solve problems where we have greater than or equal. Please visit my website at yourmathgal.com, where you can view all of my videos, which are organized by topic.